Now, skeletal muscle tissue is one component of a skeletal muscle organ. We know that the definition of an organ is a structure that is composed of many different kinds of tissues that all work together for a common function. A skeletal muscle organ is composed of multiple different kinds of tissues, one of which, the primary one of which, is skeletal muscle tissue. When you look at a skeletal muscle organ, we're going to dive in and look at basically the organ level all the way down to the cellular level and smaller than cellular level in order to kind of understand how skeletal muscles function. But there's a couple of things that you can know just from looking at the big picture organ itself. First of all, most skeletal muscles attach to bones. We've already done the bone lab, and we've done the joint lab. So if you can imagine that skeletal muscle organs attach to bones and span joints, we can shorten the skeletal muscle organ and cause a movement to take place. In order for this to happen, we need at least two attachment points. And the attachment points, this is a picture, I can't draw on it, but the attachment points, we have an origin attachment and we have an insertion attachment. The origin, and it gets super gray and muddy, and do we really want to spend a lot of time debating and figuring this out? No, not in my class. The origin is the attachment that moves the least. And the insertion is the attachment that moves the most. Honestly, it doesn't matter to me if you distinguish between those. The important thing is knowing where our attachments are. Then, once you've identified the attachments for a skeletal muscle, you can actually look at the fiber direction. Now, each one of these fibers is anatomically a fascicle, and I'm telling you that now, and we're going to look at it and write it down in the next section because the skeletal muscle organ is made up of bundles of fascicles, and the fascicles are what you can actually see, the long, thin, what are they? Like, you eat them. Like, you can shred a piece of steak, right? There's like an easy way to cut the steak with the grain, and then there's like a hard way to cut the steak where you are cutting across all the little shredded. Does anybody know what I'm talking about? I hope you're vibing me right now because otherwise, I'm sorry. But these are gross anatomy structures that you can actually see. Now, what's the whole point? The point is if you identify the fiber direction and you identify the attachments, you can actually figure out the action of the skeletal muscle. And that happens because skeletal muscle shortens along the fiber direction. What? That means the fiber direction is this way from, let's say, sternum, this is pec major, sternum to, whoa, humerus. And if these fibers shorten, look at what's going to happen to the movable attachment, which is the humerus. The humerus is actually going to move toward the torso, and that happens because of the shortening of these muscle fibers. If you know these things, you can figure out the action. The action is the movement that the muscle causes. Now, let's see, what else do you need to know? Usually, muscles come in pairs. They come in movement pairs. One muscle causes one movement, one muscle causes a deduction, and the other muscle in the pair causes a abduction. And those muscle pairs are called antagonistic pairs. Physiologically, a muscle can't actually relax itself. It needs its antagonistic pair to stretch back out into a relaxed state, which is kind of an interesting thing that we'll spend a little bit of time thinking about, but we won't get a whole lot of details in anatomy. I think the entire skeletal muscle organ is surrounded in a connective tissue sac called the epimysium, and that's where we're going to start. We're going to look at, and then the entire muscle organ is made up of various other things. So now we're going to go into what is this hierarchical organization of skeletal muscle.